Hello dear students, so now today we would move ahead in this first chapter of class 11th mathematics, that is sets. So here today we would be discussing some other sort of questions here. Okay, so the question is, which of the following are pairs of equal sets? Equal set, do you mean, what do you mean by the equal sets? Equal sets means if the elements are same in two sets. Suppose you have been given two sets. If the elements are same in the two sets, then you would be calling such sets as the equal sets. Okay, so this is the first question. You have a set A, the set of all letters in the word alloy. Then you have a set B, and this is the set of letters in the word loyal. Okay, so let's find out the elements in the set A. What are the elements? If you see in the set A, elements are A, L two time is there, only one time once you would be writing, then Y, then O, then Y. So these are the elements there in set A. Okay, now if you see the elements of set B, what are the elements in the set B? You have L, then you have O, then you have Y, then you have A, then again L is there, which already I have written. Okay, now if you see the elements in the set A and B both are equal, order doesn't matter. But if you see the elements, A is here also, A is here also, L, both A, O also is there, Y here is also, and here you have also Y. Okay, so now you can see, hence set A is equals to set B, because both are having the same elements. Hence set A and B are equal sets, isn't it? Because they have same elements, isn't it? Okay, now we will be moving towards the next question. Note it down. So this is the next question that you have to do on your own. Okay, so you have set C, so write the elements of the set C, write the elements of the set D, so whether these are equal or not, so try it yourself. And now this is the next part of the question. You have a set E that has been written in the roster form. Okay, sorry, set builder form. You would be writing it in roster form. Okay, so now you have set E. Okay, now if you see, the set E contains how many elements here? Now if you see, the set E contains the element in the form of X such that X belongs to the set of integers. Means the set E is having the integers. Integers means plus, minus, 0, all these are the integers. But condition has been given that the square of the integer should be less than equal to 4. Square of the integer. So all integers whose square is less than equal to 4, you would be writing all those integers here. So what are the integers? Those whose square is equal to 4 and less than 4. So now you have integer 0. Square of 0 is 0. So 0 would be the element here, isn't it? Isn't it? 0 would be the element here, because square of 0 is 0 and 0 is less than 4. Then take another integer, that is 1. So 1 can be the element here. Yes, square of 1 is 1. So which is less than 4. This also would be the element here. Now let's take 2. Square of 2 is 4 and 4 is equals to 4. So 2 also can be the element here, isn't it? But we cannot take 3 because square of 3 is 9. So 9 is greater than 4. But we have to take the elements in less than and equal to 4. Okay, so these are the elements. Now let's move towards the negative integers. Minus 1. If you see, square of minus 1 is plus 1, which is again less than 4. So would be there. Minus 2. Square of minus 2 is again 4 plus 4, which is equals to 4. So this also would be the elements here. But you cannot take minus 3 because square of minus 3 is 9 plus 9, which is greater than 4. Okay, so these are the elements in the set E. Now let's find out the elements in the set F. If you see, what are the elements in the set F? The set F also contains the element in the form of X such that X belongs to the set of integers. But condition has been given here, X square should be equals to 4. Exactly equals to 4. So those integers you would be writing whose square is equals to 4. So you have only two integers there, plus 2 and minus 2. Only these are the two integers whose square is equals to 4. Okay, so I will be writing here minus 2 and plus 2. So the set F contains the element, only two elements are there. Okay, so are these two sets equal? No, because here you have minus 2 plus 2. Beside minus 2 plus 2 there are minus 1, 0 and plus 1. But here you have only minus 2 and plus 2. So these are not equal sets. So hence you can say set E is not equals to set F, isn't it? So that is how you would do the given question. Note it down. And this is the next part of the question. You have a set G, and the set G contains the element, two elements are there, -1 and +1. Okay, you have set G, and the set G contains two elements, -1 and +1, isn't it? Then you have set H. The set H contains the element in the form of X, where X belongs to the set of integers, means positive, negative and 0. And one condition has been given here as x square minus 1 should be equals to 0. So only those integers you would take whose square and you are subtracting it from 1, you are getting 0. Okay, so what are the possible integers? Let's take, if you are taking 0, square of 0 is 0, so 0 minus 1 is not 0. Okay, let's take 1, square of 1 is 1, so 1 minus 1 is 0, so 1 can be the element here, isn't it? 1 can be the elements. Now let's take 2. 2 cannot be that because square of 2 is 4. 4 minus 1 cannot be 0. Okay, now take the negative 1 elements. Now let's take the -1. If you see the -1, square of -1 is +1 and 1 is -1 is 0. Okay, so -1 also would be the element here. Okay, so these are the two elements in the set H. So hence you would call, hence what? Set G is equals to set H, isn't it? Yes. So this is how you will be doing the given questions. Okay, so let's note it down. And this is the fifth part of the question. Question is, you have a set I. This set I contains the element 2, 3, and then you have a set J. That set J contains the element in the form of X, such that X belongs to the set of integers, but condition has been given here as such that the X square plus 5X plus 6 should be equals to 0. Okay, so now let's factorize it. If you want to factorize x square plus 5x plus 6 plus equals to 0, we would be getting the value of x. So whatever the value of x you would be getting, because this is the quadratic equation, you would be getting two elements, so two values of the x. So these two values means these two values would be the two elements here in the set J, isn't it? So let's find out the value of x. Okay, at direct we can find out the value of x. No need to put the integers there one by one. Okay, factorize it, you would be getting the value of x. So those are the elements there in the set J. Okay, so let's factorize this. X square plus 5x plus 6 equals to 0. Okay, so how do you factorize? 6, 1 here, 1 is there, so 6 1 just 6. So you need two factors of 6 whose sum should be equals to 4. If you are subtracting these two factors or you are adding these two factors, the answer should be 5. So we have 2 there, 3 and 2. 3 2 just 6 and 3 plus 2 is how much? 5, isn't it? So I will be writing here x square plus 3 plus 2 into x plus 6 would be equals to 0. It implies what? It implies x square plus 3x plus 2x plus 6 equals to 0. So take x common here, x plus 3, then 2 you take common here, then again you'll be getting x plus 3. So you have two values here, x, two factors, x plus 3 and x plus 2. So from here you have two values of x, plus 3, sorry, -3 and -2. These are the two elements of the set J. It implies what? It implies set J contains two elements. What? -3 and -2. Now just tell me, set I and set J both are equal. Set I you have 2 and 3, but in set I you have -3 and -2. Are these equal sets? No, because these are the negative integers. These are the positive integers here. Okay, so hence I would call set I not equals to J, isn't it? So just note it down. So that is all for today. So now if these videos that I am making for you are helpful for you, so please do like and do subscribe to the channel, and do share the link of the channel to your friends, colleagues, okay, your classmates, etc. Isn't it? Okay, thank you. That's all for today.